All right, hey there, day 5, I think. Anyway, I'm actually not feeling very good today, but the show must go on. So I think the show's gonna go on. Um, and hopefully I'll get it done despite not feeling that good. So, uh, fishing into BART as soon as final supplies have been unloaded from the ships. Supplies are stored in stacks of marked crates because they need supplies. The crates need to be arranged. So giant cargo cranes keep moving crates between stacks, ensure on the shades crane while areas of sure for the hand steps. After the crates are arranged, desired kits will be at the top of each stack. Just don't want to interrupt the crate operator, but they forgot to ask her which crate will end up where. They don't want them to embark. They do have a drawing of the starting stacks of crates and the rearrangement procedure. For example, move 1 from 2 to 1. Move 3 from 1 to 3. Move 2 from 2 to 1. This example, there are 3 stacks of crates. Stack 1 contains 2 crates. Crate Z is on the bottom. Crate N is on the top. Stack 2 contains 3 crates. Finally, stack 3 contains a single crate P. Okay, then the rearrangement procedure is given. In each step of the procedure, a quantity of crates is moved from one stack to a different stack. In the first step of the above arrangement procedure, one crate is moved from stack 1 to stack 2, resulting in this configuration, TC. Okay, there's 3 crates moved from stack 1 to stack 3, so it's moved 1 at a time. So, okay, then both crates are moved from stack 2 to stack 1. Yeah, because crates are moved 1 at a time, crate C ends up below crate M. Finally, one crate is moved. That you know which crate will end up at the top of each stack. Okay. All right, that seems reasonable enough. So we need to do, the hard thing is going to be parsing. As always, parsing is the most difficult. So let's put this here. Okay, and that's clever. That's good thinking. I like the way you think. But from data classes, import data class. And then what are these things called? These things are called a stack, which stacks. Okay, so let's just say a stack is a list of strings, and stacks is a list of stack, and data class, that's right. That's not right. Move. Why is from a reserved word? Maybe it is. Okay. Let's say quantity at uh, uh, let's say from. I'll just do it that way. That's fine. Def parse. Um, and I want to import RE because I want to use a regular expression. And let's say that move regex equals okay, that seems right. And let me just test something out in my thing to make sure that I do it correctly. Import RE. Because I can never remember the exact syntax. And so, and let's say text2 equals text plus n plus text. And I want to try re.find all move regex text2. That seems to work. All right. So, um, uh, but I'll do this differently. Get moves, raw, which is a string to list a move, return move, row for row, and re dot find all move regex. Okay, so that should be good. And now, um, um, and so let's say data class problem, and a problem is going to have stacks and moves, which is a list of move. So that's right. It did that for me, which is good. And let's say def get problem, raw string to problem. And what I want to do is I want to say raw stacks, raw moves equals raw split on n. Stacks equals dot dot dot, moves equals get moves, raw moves, and return problem stacks moves. Get stacks, raw stacks. Okay, so this will be the interesting part, I think, which will be raw, which is a string, and is going to return stacks. And so here's my thinking, which is that let me just use this as a scratch paper. If I take this and transpose it, right, then all I care about is really the so let me do this here and say raw equals this raw, right? And then if I say line lines equals raw dot split on new lines, and let's say lines. Okay, and so each of these, and now I want to do reversed lines. Okay, and now what I want to do is okay. So get stacks. So let's say lines equals list of reversed raw dot split lines. Okay, that's good. And now, and let me look at what this looks like, because this is going to cause me a problem if there's actually like multiple digits. So let's see how this works. But there's not multiple digits. Perfect. So that's good. I might be cheating a little bit by doing that, but okay. Calls equals I for I and enumerate lines 0 for IC. Actually, let me do it this way. let me do equals addict from int to stack. Okay. Um, and okay, so now what I've done is I've basically a map from one to call, um, and then what I want to do is uh, let's see, lines equals that. Um, if C is not that. Okay, so that's one bug already. If C is not empty. Okay, um, and then let's say stacks equals line call. Uh, yeah, so I think that's right. Um, uh, so what I really want is I want C line I for line, if line I is not that, for C I in calls dot items. Let's see that. So that will be one is Z and N. One is Z and N, two is MCD, and three is P. So that seems right. Return stacks. Okay, good. Um, um, and def move, and I don't want to start with the problem. I want to start with some stacks, which are stacks. Um, and, uh, and let's call this perform move, which is a move, and it's going to give me a new set of stacks. And for blank and range move dot quantity, stacks move to append stacks move from dot pop. So that's exactly what I want to do, right? Where I want to move from, I'll pop off the latest thing, and then I'll move it to stacks move to. And then I do want to copy. So for copy, so let's say stacks equals copy dot. You know what? I don't care about that. This is going to burn me. Okay. So we'll just do run self, which is none. For move and self dot moves, self dot move move. Okay, that's fine. So then move self move move to none. From stack. Yeah, that's not what I want to do. I want to do self dot stacks dot move to dot append self dot stacks move from dot pop. So that's what I want to do. Okay. And then so I have raw, and so let's say problem equals get problem raw, problem dot run, and then assert, and let me, one more thing, I just want the tops, right? So def tops, what are they asking us to do? You should combine these together, which create top. Uh, Join stack -1 for stack and stack stack values. Here I'm counting on them being in the right order, but they should be. So assert top of problem dot stacks equals CMZ. All right, so let us, it should be tops. So let us run that and see what we screwed up. Key error 1, self stacks move to equals self stacks move from. Right. So what I need to do is I need to convert these to int. I thought about using map, but I don't believe in using map. So okay, so let's see what I did wrong. Okay, problem.stacks. Okay, let's add some debugging. Print move. Print self.stacks. Okay, so let's run this and see what happens. Okay, move quantity 1 from 2 to 1. So D goes there. Move quantity 3 from 1 to 3. So I only moved 1. So it's only moving 1 at a time. So oh, right, self.move. So for blank and range move.quantity. So that's the issue, is that I ignored the quantity. And now it works. Okay, good. So now I can take these print statements out. Let's get my puzzle inputs. I already got it. Okay, so now with open day05.text as f, raw equals f.read, problem equals get problem raw, problem.run, print tops of problems.stacks. That should be good. Let's see if this is right. I don't like that it has the same thing in there twice, but maybe that's okay. Yeah, the same things are in there twice, so all right, that's all right. I'm worried this won't work and then I have to debug it. Oh, good, that's the right answer. Okay. As you watch the crane operator expertly rearrange crates and find your prediction, submud was covering the writing. It's not a crate mover 9000, 9001, including the ability to pick up and move multiple crates at once. Again, considering the example, both crates being in the same configuration, moving a single crate, however, the action of moving 3 crates from stack 1 to stack 3 means that those 3 moved crates stay in the same order. Next, as both crates, they retain their order as well. Finally, the single crate is moved, but it's crate C that gets moved. Okay, know where these what crate ends up on top of each stack. Okay, so this should be straightforward too. We just need to figure out what the cleanest way to add this is. Um, so uh, let's call this model int equals 9,000. Okay, so if model equals 9,000, if model equals 9001, self dot move 9001 move. Otherwise, raise all your invalid model. Okay, so um, def move 9001 self move, which is move, and that's again going to do none. Okay, no. Okay, and so to move equals self dot stacks move dot from minus move quantity to the end. Okay, so that's right. Self.stacks move front equals self.stacks from, so truncated. Okay, that's good. And then self-stacks move 2 plus 2 to move. Okay, so that seems right too. So instead of popping them off one at a time, I take the last however many, chop them off, and then stick them on the end. So these are like lots of inefficient operations. So, so let's try this. So if I try doing it with model 2001, it should be MCD. And assert tops equals MCD. Is that right? MCD? MCD. Okay, so let's try this and see if it works. All right, good. So now let us do the same. And we destroyed it, so we got to do it again. Model equals 9001. And now let's run this. And we've got this DCV, whatever. That is the right answer. Okay, good. So, yeah, a lot of the pain here was just parsing this into the right format using regexes, and then this idea of reversing it and just reading across or down the rows. And then other than that, still hate this from, but you know, it worked. So that's that. Hopefully I feel better tomorrow because I don't feel real good right now. But anyway, uh, awesome. Hi everyone. All right, take care. I'll see you tomorrow.